All right, welcome to topic 3-4. Example 1 walked you through the idea of using our part equals percent times whole idea to work with the idea of percent change, as that's our focus of this lesson. So today we're going to continue working with that in example 2, but this time we're going to see a slightly different scenario. It says that a website had 40,000 visitors this year and it had 37,000 visitors. I read that wrong. Last year, a website had 40,000. This year, they had 37,000. What is the percent change in the number of visitors to the website from last year to this year? So as we're looking at the diagram here, we're noticing that there's a decrease compared to an increase this time. And so how is this going to affect our problem? Not too much differently. We're going to still use the same formula that we used last time. We're going to use this idea of part equals percentage times the whole, and we're going to plug in those same ideas. So throw the equal sign. We don't know what the percent change is, so we'll just put in P for percentage. Whole is the 40,000 because that's what we're working with. I gotta practice with my stylus more, I guess. Not very neat. And of course, the part then is going to be the part that's changed. So how much? And so that's looking at this white part right here. And to understand that white part, you kind of got to do some initial math first. You actually got to calculate that change, right? And so to find the change in length, I'm going to take this 40,000 and I'm going to subtract this 37,000, and then I'm going to go ahead and solve and get 3,000. Nice and small, and so our part is actually 3,000. Right? So a little bit of thinking about the numbers beforehand and understanding what they're really asking as that part. But then you can solve this and continue. All right, then from here we can see how the problem kind of plays out. We have the 3,000 there, 3,000 and the 40,000, and you can see how they rearranged it to be 3,000 divided by 40,000. And then I'm going to have to cross this out. Don't memorize that because they did their math wrong, because 3,000 divided by 40,000, right? Or in other words, 3 divided by 40 is 0.075. And I know that because 3/4 is 75, so if I put a 0 there, I'm going to have to move over one decimal place. Now, with that in mind, now we can agree with the final answer as we're working with a percentage then. So we want to change it back to percentage. So we're going to multiply by 101.2, and that's how we get our 7.5%. So we have that for our second example. So far what we've seen is we've seen an increase, a decrease. Now let's move on to example 3. As you look at example 3 then, we add in a new concept. It's called percent error. And it looks like my window is cutting it off a little bit. And still cutting it off. So it says percent error describes the accuracy or measure estimate value compared to an actual value. It's always a positive percentage. And to make sure it's always a positive percentage, that's where we're going to add in the idea of absolute value. So let's take a look at how this works. Sean estimated the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296. What is the percent error of Sean's estimate? Round to the nearest whole percent. So what we're seeing here is we're subtracting these two numbers, 3,000 minus 3,296, and then we're taking the absolute value of them to make sure that we have a positive number so that we can get a positive percentage. So in that case, we are able to do that, and then we just plug things in. So instead of percent, we're going to call it percent error. So our equation part equals percentage times the whole. All right, our percentage is our percent error now, And our part, of course, is the difference in attendance. We've seen that idea before. And then the whole is everyone who did attend. So that would be that. And then it's all about setting up our division problem and then solving that division problem, which we see is approximately 0.898, and I believe that's a repeating decimal. That's why it says approximately, not for sure. And then after that, you can see because we are estimating, we can round it up. So once we multiply this number times 100 to turn it into a percentage, or multiply by 100%, then we're going to get 0.898 percentage, and so we just round up because it's an estimate, so it's about 9%. So we're looking at that concept there. So percent error basically just takes in this new, not a new idea, but additional step of using absolute value to find a positive difference, which that just sounds funny. That's an oxymoron. Yes, I just said oxymoron. Hopefully you know what that means. If not, that's a good question to ask in class. All right, that's it for lesson 4. Bring your questions if you have them.